Hi, welcome back to Make Sense of Math. I am Michelle and I am so glad you are here. Today I want to talk about why I do not use the FOIL method when teaching multiplying binomials and what I do instead. The reason why is all based off my belief that you need to set students up for success. That could be success in future math classes or success in their future careers or their lives in the future. But you need to look long-term for your students and think, how can they be successful with this idea and not just teach to the test so that they pass the next chapter test or the next unit test or the end of year test, that they're always have a mathematical principle that they can carry on, and that is true. So some examples of what this might look like in an elementary classroom and would be something like, well, just any classroom, honestly, not just elementary. But for example, subtraction. Maybe they are given a word problem and they know they need to subtract, and the teacher might be like, well, we always got to do our bigger number first because you have to take your bigger number and then minus your smaller number. And that's not always true. I mean, probably in their grades it is true because they don't deal with negative numbers. So in their grade, they are always doing the biggest minus the smallest. But if your students have that concept that it's always the bigger number minus the smaller number, then when they go into future math classes, they have to reconstruct their meaning and realize that subtract's not always a bigger number by minus a smaller number. This could also be true with multiplication. Maybe somebody would say a multiplication always makes the number bigger. Again, not always the case. When you get into multiplying by decimals or fractions, it often makes the number smaller. And I also see this with the equal sign. Maybe you will say that the equal sign means that it's the answer. And equal sign doesn't mean it's the answer. It means that those two expressions on both sides are the same, or that the equation is balanced. And if students have this concept of the equal sign back, even in first grade or kindergarten when they're using it, then when they go into equations, that will have such a better foundation for them. So this is all to say why I don't use the FOIL method is because it does not build upon itself. When they go into the future math classes, the FOIL method no longer works for multiplying polynomials because you are suddenly multiplying maybe a binomial by a trinomial, and the FOIL method goes out the window. And if they don't have a mathematical basis for it, they have to reconstruct their meaning of what does it mean to multiply polynomials together. So if you don't even know what the FOIL method is, let me show it to you, although I do not promote it. So if you have, for example, x plus 2, and you're multiplying that by x plus 3, then FOIL, it's an acronym for each what you do. So the F would start for first. That means you multiply the first terms together. You would say x times x is x squared. O, outside, you multiply the outside terms. So x times 3 is 3x. Inside would be the inside term, so the 2 and the x, it's 2x. And then last would be the last term, so 2 times 3 is 6. And while, yes, it does work for this, multiplying binomials, it will not build on itself, because suddenly when you're multiplying x plus 2 times x squared plus 2x minus 1, for example, first, outside, inside, last doesn't work because you have this extra 2x here. And if you just multiply, what does inside even mean at this point? 2 times x squared, then when does the 2x get into place? So it only works for binomials, and that's why I don't use it, because it's not mathematically based. So when I am teaching this, everything is based off of the distributive property. And the distributive property is based off of multiplication. So I go back and we review, what does multiplication mean? And I ask my students, what does multiplication mean? And there's some that can't give me a definition. They probably knew it really well when they were learning multiplication, but maybe they just have their facts memorized and they kind of lost their meaning behind it. But a lot of them will say repeated addition. And I say, yes, that is absolutely true. It does mean repeated addition. And some of them will say it also means groups of, and it does mean groups of. I say it means both of those are accurate. I said we are going to go with the groups of, because when you are repeating addition x times, it gets a little bit too abstract to understand. Groups of makes a little bit more sense. Now, when I teach the distributive property or any of these multiplying binomials terms, I always use algebra tiles first. That's my concrete. And I'm not going to go over algebra tiles in this video. I love them so much that I have a course on it, Algebra Tiles Academy. So if you want to know more about algebra tiles and how to use them in your classroom, then I will drop the link down below, Algebra Tiles Academy. But it not only teaches you how to use them for certain mathematical concepts, but how to start with algebra tiles as a means to an end. Obviously, you don't want your students always using algebra tiles because you want them to be able to solve it abstractly. So I kind of guide you through a process that I have used and I found so effective so that they understand. Okay, so I'm not going to do the concrete in this. I will show you a little bit of the abstract that I do. Sorry, not abstract. Yes, abstract, but sorry. So I'm not going to show you the concrete. Second step would be representational, and I will show you that, and then that moves to abstract. But we start with basic. We start with what does 3 times 5 mean? And we talk about that. 3 times 5 means 3 groups of 5. And we will write that, 3 groups of 5. Sorry, it's a little bit harder to write on this worksheet on a computer. But so 3 groups of 5, and we will show it representationally, 3 groups of 5. And I always like to circle my group so that they can visually see that it's a group. And 3 groups of 5 is 15, right? Because the answer is the total, right? So then we may jump to like what number 6 says. What does that say? It says 3 times y plus 2. What does that mean? It means 3 groups of y plus 2. So we will show y plus 2 1 group, y plus 2 2 groups. Total is, oh, sorry, that's 2 groups. There's a third group. So that's 3y plus 6. And then we show that. And I go over distributive properties so much, how the first terms are getting multiplied by everything in the second terms. Now, how does this connect to let me erase this real quick. How does this connect to multiplying binomials? Well, multiplying binomials is using the distributive property. Let's start with what we started before. X plus 2 times x plus 3. Distributive property, we're multiplying these terms by these terms. So every one of the first terms need to get multiplied by every one of the terms in the second one. Now, always, 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 especially at the beginning, have your students circle the terms. And be very specific that they need to circle the sign in front of the term. So for example, x, there's no sign. That means that it's positive. It doesn't say a plus sign, but the absence of a negative means it's positive. And I will say that. I mean, it seems like obvious to say that, but they need to hear it. So this plus implies that this 2 is positive, right? If there was nothing there, it would get confused with the x and it would look like multiplication. So be specific there. And then this is again is a positive x and this is a positive 3. So circle your terms. Now, representationally, you can show it like this in arrays. And I would bet that, most of your students, if not all of your students, feel really comfortable with arrays. I know at least in my students' grade school, their teachers are really good about arrays, and that needs to continue through middle school. It's just a really good way to keep building on their prior knowledge. So you're going to put every term on one side, and then every of the first binomial, and then every term of the second binomial on the other side. And I knew it was a 2 by 2 because there's 2 terms here and 2 terms there. And you're going to multiply. X times x is x squared. X times 2 is 2x. Now it's a positive 2x. I don't need to write the positive, because the absence of a negative means positive. 3 times x is 3x, and then 3 times 2 is 6. Now I'm going to combine like terms. So I have x squared, and then I have 3x plus 2x, right? 3x plus 2x is 5x. Now again, I need to write my plus there, because if I don't, it's going to look like multiplication. So plus 5x, and then my last term is plus 6. So I would recommend doing arrays, because when they get doing multiplying the binomial by the trinomial, like if they have x plus 2 times x squared minus x plus 3. Now this is going to be a 2 by 3 grid, right? So 2 by 3, and I'm going to write every term of the first one on one side. Now you can even have skim. Does it matter which side I write the terms on? Like, does it matter if I write x plus 2 on one side versus x plus 2 on the top? And it's a great conversation, and you would say no, because order doesn't matter when you multiply, right? And then x squared, and I need to write my negative x here because I need to know that it's negative, and a 3. Again, I didn't circle the terms on this one, but I would so much recommend circling terms. Students will eventually stop doing it, and if you notice that they're not making the mistakes of the signs, then maybe let it go. But if they are still making the mistakes of signs, encourage them to circle the terms. And then they go through and multiply this. I'm not going to go through and multiply, but you can see how you would do it. X times x squared is x cubed, and oh, that's a 3. And x times negative x is negative x squared, and go through, multiply it, and combine like terms. So that's the abstract way that I would do that. Now, sorry, that's representational way that I would do that. Abstractly, let's go back to the basic here. So if I have x plus 2 times x plus 3, you're making the same point that you're multiplying every term in the first binomial by every term in the second one. The way that I have my students do this is draw lines, because it can be really confusing, like, have I done that one? Have I not done that one? And so we draw lines. Okay, this x needs to be multiplied by every single term in the second binomial. And so I'm going to go x times x. That's x squared. X times x is 3x. And then we can do it, I sometimes even do it on the bottom for the next term. 2 times x is 2x. And again, I need to write the plus so that doesn't look like multiplication with a 3x, and then 2 times 3. And drawing those lines helps them visually see what they are doing. Again, why are we doing this? Because when they get into their future classes and they are multiplying binomials by trinomials, or even binomials or trinomials times trinomials, it can get so confusing, but everything is based off of the distributive property. That is the mathematical principle. And if they understand that, then they can apply this concept. And it also is very helpful when they get to factoring. If they understand what's mathematically happening when they are multiplying, then undoing it to factor it has a little bit more like meaning to it. So anyways, that's how I teach multiplying binomials, because it builds a foundation for continuing on to teach the trinomials and on. Like if they understand the distributive property so well that they can apply it to any concept of multiplying binomials and also undoing it to factor, that is going to set them up for success. So no more FOIL. Distributive property is what you're going to want to do. Let me know if you have any questions, and have a good one.